Forward. So we're working on 3-2. So our next exam is 2 weeks away, right? Yeah, it's on the. You guys have the schedule. It's 2 weeks from today. Week after next, Wednesday the 18th, is our third exam. 5 exams total. All right. So we're talking in this section. You guys make it through that terrible 3.1 homework? Was that kind of difficult? Yes, no?
Yeah, if you messed up one part, you got to do the whole thing over.
Yeah, that's why I was kind of suggesting just go through it once, kind of write it down, go through it again. Because they use weird words, don't they? That's the trouble I had as I was doing it. And also they take different steps than I would think to take at different times. So anyway, on the exam, it won't be that way. It'll just be the original question, and then you provide the answer. You won't have to give words or anything like that. All right. Well, let's move ahead. So it's a more normal section here. So this is the section where we have the two formulas about adding and subtracting angles. We started it last time. So if you have the sine, let me just write them both again real quick. Sine of A plus B, if you have two angles added for sine. So remember him, he's sine, cosine, cosine, sine. Right, that's the pattern. Sine, cosine, cosine, sine. A, B, and sine is your friend, meaning he's easy. He keeps the same, if you start with plus, and then you keep plus. If this had been minus here originally, then this would be minus. It's the same. Sine just keeps the same. Of whatever plus or minus you originally had, it does the same. And then cosine is not your friend. Cosine A plus B is cosine, cosine, sine, sine, and AB again, AB. But he does the opposite. If you start with plus, he does minus. If you start with minus, he does plus. He does the opposite, right? So you put those on your 3x5 card. There we go. So they want me to do cosine of 45 plus 150. Let's do it. What's it going to be? Cosine, cosine, sine, sine. And then you just go 45, 150, 45, 150. So 45, 150. 45, 150, and cosine is not our friend. He does the opposite, so that'll be minus, because this one started with plus in the middle, so that'll become minus. Like that? Okay, so there it is. There's basically what we need to do. We got to figure all those out now. We got to figure that, bless you, with cosine of 45, sine 45, and then both those for 150. Okay, so here we go. We'll go to 150. This problem sure looks familiar. Did we do this one? Did we do this actual one? Oh, okay. Yeah, it sure felt familiar. All right, I'll finish it up here since I'm almost done. So you just do 45-degree angle, right in the middle. That's an easy one, huh? Sine and cosine are both middle. Remember the small, medium, large? They're both medium. They're both root 2 over 2. So cosine and sine are both root 2 over 2. Root 2 over 2, and then the 150 degrees, where's that? Well, 180 would be right. This is 180, so 150 is just barely up from that. We good? 150 degrees is right there? Like that? Okay. So, what does that mean? That means you got to go back a large amount. So this is root 3 over 2, only up a half, huh? See how it's back a lot, only up a little? And so the cosine, and this is back, so it's actually negative, and this is up, so it's positive here. This is sine. Cosine is x, sine is y, always on the unit circle. So cosine of 150 is negative root 3 over 2. Sine of 150 is positive a half, and there's a minus in the middle. We good with that? Or with the signs, you can do the all students take calculus. That's how my daughters always preferred to do it. All students take calculus. So in the second quadrant, which is where 150 is, everything's positive in the first quadrant. All are positive. Second quadrant, only sine is positive, and his reciprocal, cosecant. The others are negative. So sine is positive, of course, and cosine is negative. That's the other way. So sine is going to be positive, and cosine is going to be negative in 150-degree second quadrant. Okay, multiply together. Root 2, root 3, and it's negative. Negative root 6 over 4, right? 2 times 2. Minus Root 2 times 1, root 2 over 2 times 2, 4. So there we go. Put them together. You cannot subtract those on the top. That's just it. You can't make that root 8 or something. Those are just unlike terms, and we're just done right there. Remember that? Remember the rules of roots from algebra? You can't add them or subtract them when they're different roots. It's like having different letters. It's like minus x minus y. You can't put them together. They're unlike terms. So that's it. Again, there's the answer. All right, let's move on. So how far did we got? We got through 5? What's number 5? Bless you. Okay, so tangent. Now let me look in the book because I always just do everything with sine over cosine, but I don't want to make you do the harder way. Yeah, there is a formula. Let me just give it to you. I opened right to it, luckily. Let me just give it to you. You can do whichever way you want. I just always did tangent by doing the sine rule over the cosine rule, but that's just because I don't like to memorize extra things. So anyway, let me just it's probably easier just to do the tangent rule. Let me give you the tangent rule. So tangent of A plus B. Here it is. It's coming right out. I got the book here. So because I do not have it memorized. Tangent A plus tangent B over 1 minus tangent A times tangent B. So there it is. There's the adding. Well, there's the tangent of two angles added formula. Notice the signs. This is plus, and that makes this one the same and that one the opposite, right? So can you guess what the tangent of A minus B formula would be? It's going to be the same thing, but all the signs reverse. So it would be tangent A minus tangent B on the top, and it would be 1 plus the tangents multiplied on the bottom. Does everybody see that? See how the signs follow suit? Is that making what I mean by follow suit? Follow the pattern. So if the original one's plus, you end up with a plus and then a minus. And if the original one's minus, they reverse. Both of them reverse. And that's how all these formulas work, right? When you go from the adding of two angles to subtracting of two angles, all the angles in all the signs in the formula switch. So you don't really have to write both of them down if you know that pattern. You can just write the plus one down, and you'll know how to do the subtraction one. But you can put them both in your 3x5 card if you want to. Okay, so anyway, so we are adding two angles here. So the adding of two angles, how do we do it? Well, according to that formula, it's tangent of the first, this is A, and this is B. So tangent of the first one, pi over 6, plus tangent of the second one, 5 pi over 4, over 1 minus tangent of the first one, pi over 6, times tangent of the second one, 5 pi over 4. So there we go. Now we just got to figure out what all those little things are. But there's the setup. Let me get rid of this one. We don't need this one right now. Okay, so we've got to figure out what the tangent of pi over 6 is and what the tangent of 5 pi over 4 is. And then it's the same thing here, same thing there. So really we just have two things to figure out, don't we? So we got to figure out the tangent of pi over 6. I don't like radians. I don't naturally think in radians. So I just stick in a 180. Remember, pi is 180 degrees. So that's the tangent of 180 over 6. That's the tangent of 30 degrees, isn't it? So that's a 30-degree angle. So let's do that one first. 30-degree angle. Here it is. 30 degrees. That's the first one of the three. 30, 45, and 60. It's the first one, 30. So that's over a large amount, up a little bit, isn't it? You guys with me? Maybe I should let you get it instead of just whipping it out. You might get more out of it. So give it a try. Finish that up. Find the tangent of 30. I'll let you do it first. Find the tangent of 30. So you guys, is this making sense in the unit circle stuff? I am glad to answer questions. Make sure this is making sense for you. Please ask. Everybody always has the same question, so don't feel alone. Please ask any question. If that seems weird or it's still seeming weird, I'd like throughout the semester to make that more and more clear and comfortable for you. Is that making sense? There's 30, 45, and 30, 45 is in the middle, and then 60 is up here. In fact, I probably made that 30 up a little too far. It's like more like right here. So 30 degrees. So it's up. It's over a large amount, up a small amount. Remember the small, medium, large, right? Small, medium, large, right? 1, 2, 3. Small, medium, large. Over 2. The root of 1, the root of 2, the root of 3. Root of 1 is just 1. Over 2. That's the small, medium, large. And I just mean that's over a lot, up a little bit, isn't it? So it's over the large, up the little. Okay, and the cosine is always the x. The sine is always the y. On that, right? We good with all those facts? Okay, and so what does that all mean? Well, the tangent, what is tangent? How do we find tangent? So we sine over cosine. Remember that? So tangent is sine over cosine. Exactly. So, in fact, let me bring it down so I have room over there to do the other one. So there'd be sine of 30 over cosine 30. So what's the sine? That's the half. And then the cosine is root 3 over 2. Is that good? So sine over cosine, the half over the root 3 over 2. And then the bottom flips up, that whole thing, right? So we get a half times 2 over root 3. The 2's cancel. 1 over root 3. Now, I know we don't usually leave roots in the bottom. I'm going to leave it for now, though. I'll fix it later. But for now, because I'm not done yet. I got to plug it all into this big thing in a minute. So I just got one piece of the puzzle. The tangent of pi over 6 is 1 over root 3. Again, I'll just leave the root in the bottom for now. Simplify later. Is that good so far in that part? Okay, please speak up. I'm glad to help if something seems weird. Okay, so now let's go over here. Oops, come on. And let's find the tangent of 5 pi over 4. Can you do that? So try that on your own. Let me give you just a second again. So find the tangent of 5 pi over 4. So put in the 180 degrees, right? Pi's 180, right? That pi is 180. So do that on your calculator. What is that, 225? Tangent 225 degrees, right? Because your pi is 180, right? So just stick in the place of pi the 180 degrees. You good with that? And then that's tan of 225. And then I'll let you do the next step. Put that on the unit circle. Put that on the unit circle and find that spot. So 225, that's 180 plus 45, isn't it? Right, 225. So what does that mean? It's down here, because here's 180. So it's halfway past 180, isn't it? 45 more. So which means it's a medium spot. Those are nice. Medium spots are nice. So I would just say, look, it's medium, which means what? What does that mean? Sine is root 2 over 2. So is cosine. They're both. Everybody with me on the medium spots? The spots that are halfway in the quadrants, 45 degrees into any. Now I'll do the signs. I know one of them might be one of them's positive, one of them's negative, or both are negative, or something like that. I'll do that in a second. I can fix all that in a second. Not a problem. All students take calculus. I'll do that in a second. Fix the sign. But just as far as the numbers go, they're both medium, aren't they? Right? Whenever you're in the middle of any quadrant, sine and cosine both medium. It's nice. You don't even have to think hard about large or there's both medium, right? Okay. So what does that mean then? Now what I really want though is tangent. What's tangent? Well, you know it's sine over cosine. If they're both root 2 over 2, root 2 over 2, then what's the tangent? 1. I mean positive or negative, we'll work that out in a minute. But the number's 1, huh? And that's true. Tangent in the middle, at any of the 45-degree middle of the quadrants, is always 1, isn't it? Because sine and cosine are both medium. They're both root 2 over 2, root 2 over 2. Tangent's always 1 in the middle of the quadrants, isn't it? So tangent's 1. Now, is it positive 1 or negative 1? Now let's worry about sine. Well, all students take calculus. We're in this quadrant here where tangent is positive. So it's positive 1. I never even worried about what sine and cosine were. Just go right to tangent. Tangent's what I want in the end. Tangent is positive 1 in that third quadrant, 225 degrees. So we got the tangent is positive 1 of the 5 pi over 4, and over here we've got the tangent of the pi over 6. And that one was positive as well because that was first quadrant. Everything's positive in the first quadrant. All right, so we've got the two. Now we have to stick them into this awful thing. Are you ready? I'm going to put them into that. Now I'm going to kind of erase some stuff and put it in there now that we've got it. These are kind of long problems. All right, so we've got all that. So now, here we go. Tangent of pi over 6, what's that? 1 over, I just erased it, but it's 1 over root 3, right? Plus tangent of 5 pi over 4, that's 1, over 1 minus tangent of pi over 6 again, 1 over root 3, times tangent of 5 pi over 4, positive 1. Are we good so far? Yeah?
Are we not supposed to leave the roots on the bottom?
Yeah, in the end. Good question. In the end. So when I'm all done, but for now, I don't want to mess around with like partly simplifying because it'll be undone based on where it's plugged in. Am I making any sense? Simplify at the end. Let me just say it that way. Yeah, not to the very, so I'll just kind of leave everything until the very, very end because otherwise you'll end up simplifying twice, like halfway through and then again, it's a lot more work. Yeah, so at the very end, you are totally right, though. We have to get rid of the roots in the bottom in the end. Okay, now what do we do with that thing? I would actually multiply these guys first. So you got 1 over root 3 plus 1 over 1 minus 1 over root 3, right? Because 1 over root 3 times 1, that's just 1 over root 3. Good so far? Okay, now, are we all feeling alert and paying close attention? Because this important step, it messes up a lot of people. Let me be helpful to you on this. This is fractions over fractions, isn't it? And it's not just one fraction on the bottom. Notice I can't just grab these guys and flip them up because there's two things. There's not just one thing. If there wasn't the one there, if it was just 1 over 3, yeah, I would just flip it up and multiply both those. That would be what I would do. But there's two things. There's a 1, and you can't flip up two things. Pluses and minuses glue things together. Anyway, so you can't do that. So what do? Let me write a note, in fact, over here. What I'm going to do, I'm going to multiply everything by the common denominator. So let me write that, because that's really important. This will come up a bunch on this one. Takes some practice. So when fractions over fractions, two cases. If there's one fraction top and bottom, just flip up the denom. You know, we know that. We've done that before. If there was just one fraction down here, boom, I just flip it up, right? That's what we do. We've done that several times. Number 2, if there's two fractions, 2 or more fractions in the denom, right? If there's two, yes, I should have just, over here I should have said one fraction in the denom, the denominator, just flip it up, just flip up the denom. If there's two fractions in the denominator, multiply all terms, top and bottom, by the LCD. It's a little more complex. So in other words, If there's more than one fraction in the denominator, right? Two fractions in the denominator, you've got to multiply all the terms, everything, all four of these guys, because you got to do the same thing top and bottom, by the LCD. What's the LCD? Well, you look at this denominator and you look at that. Those are the two denominators, the only denominators. And what are they? Well, they're both just root 3. So that's the LCD. So multiply by root 3, root 3, root 3, root 3. Everybody tracking with me? See how I'm handling this totally differently when there's more than one fraction on the bottom? Or more, technically it's more than one term. On the bottom there's a 1 and a 1 over root 3. Now why will this work? Well, these root 3s, I'm doing it's legal because I'm doing it top and bottom, so I'm not really changing anything, right? Keeping the balance. Notice how in math, right, do you see the pattern? Because you want to get the logic, because otherwise it just seems like there's a million things we do. Who knows what we're going to do when? We just random. No. Here's the pattern. Anytime you bring something new, that's new, right? That root 3 wasn't there. Where did he come from? He wasn't part of the original. Yeah, I brought him in new. When you bring in something new, you have to do it with balance. There's two ways to do balance. Top and bottom of a fraction or left and right of an equal sign. That's like 95% of what we do in math. Bring in new things with balance. Top and bottom for a fraction, left and right for an equation, equal sign. Right? That way you're not changing anything. That's logical. It's reasonable, right? So I'm doing the same thing top and bottom. All the terms on the top, all the terms on the bottom. All right, what happens? What's root 3 over 1? These cross cancel. That's why we like it. It'll get rid of those extra fractions. So same thing here. This root 3 over 1, it'll cancel. See how it canceled both those guys out? Because it's over 1, right? Cross cancel. Remember cross canceling? So what's left then? This will leave. What's left here? Just 1. Plus, what's left here? 1 times root 3 is just root 3. Over, what's here? Root 3 times 1 is root 3. What's here? 1. Now, why is that so great? Well, it's not fractions over fractions anymore. It's just a normal fraction. You with me? That's cleaner. That's quite a bit cleaner. Now, we're not quite done, unfortunately, because we still have a root in the bottom. I have to do something else. This is a hard problem. Got to do something about that. But that step we just took was necessary. Does everybody see that? See how I took it from being what we call a complex fraction, fractions over fractions, to just being a normal fraction now. It's not quite as ugly, right? Now, unfortunately, we can't stop here because, yeah, we have the root in the bottom. Now we have to deal with that root in the bottom. Boy, this is a long problem. I got to write a whole set of instructions for that. Anybody know what do we normally do to get rid of the root in the bottom?
Multiply by the root.
Yeah, multiply by the root, right? Isn't that what we always do? Like if we have something like, I don't know, 7 over root 3 or whatever. How would we can't leave an answer that way, right? How we get rid of the root from the bottom? You just go, oh, no problem. Multiply top and bottom, right? See, there again, there's a balance, top and bottom, right, by root 3. And what would you get? 7 root 3, and what would the bottom, what's root 3, root 3? Plane 3, and, just two of the same roots make a plane whatever, huh? So, yeah, and that'd be great. That would work beautifully. That's exactly, you've done that several times. You all know about that. That's correct. That won't work here. Won't work here. Why not? What's the problem?
That -1.
Yeah. Let me do it wrong. Don't write it down. But just I think it's instructive to see it done wrongly. Is that a word? Wrongly, incorrectly, and then learn from it, and then I'll show you the right way. Some of you, will anybody remember from algebra? How do you do that? That's a certain thing you go over in algebra. Do you remember it?
Conjugate.
Yeah. Good. Ben. Right? Good memory, Ben. Do you remember the conjugate from algebra? When you have a root with a plus or minus sign, you need to multiply by the whole thing, opposite sign in the middle. It's called the conjugate. Here we are. The reason people have trouble in math. Let me say this, and I'm not trying to condemn you, but to give you encouragement on what you need to make it, because I want you to make it. It's remembering old stuff. It really is. I mean, ask any math teacher, what's the biggest challenge for math students? It's remembering the old stuff, because math builds, huh? It's not like many subjects which are separate. History, I love history, but so I'm not putting it down, but it's just separate. You know, American history, then you go and take European history. I mean, they're a little connected, but not that much. Math's like a language. Chinese 1, Chinese 2, Chinese 3, Chinese 4, Chinese 5. You can't forget the earlier stuff. So here we are. Do you remember from algebra how to handle roots with a plus or minus sign? Well, my experience has been 95%. No. 95% of the students, or they vaguely sort of half remember it, but not exactly. Me either. Me too. I didn't have this perfect, beautiful love for math and remember every fact all the way up. But I say all that to say you need to review this stuff. I don't mean to get your old books out or anything, but I mean make sure you get it as we go through. Make sure you get it right now as we go through. Yeah, you need to multiply by the conjugate. Oh yeah, I was going to do it the wrong way. Forget it. I'm not going to do it the wrong way. I don't got time for that. You got to multiply by exactly what you have in the denominator, opposite sign in the middle, top and bottom like that. Does that make sense? So let me write a note on that. When you have a root, and the whole deal is the plus or minus. Plus and minus is what make algebra hard. So all those plus and minuses, and plus or minus in the denom. So when you have a root and a plus or minus, that's the problem. Plus and minuses make everything hard. They glue things together and mess it all up. When you have a root and a plus or minus denominator, you must multiply by what's called the conjugate. I'm not going to quiz you on the names, but if that helps, there you go. Multiply by the conjugate, which means opposite sign. It means opposite sign in the middle. Let me be really clear on that. That is my job. Opposite sign in the middle. In other words, guys and gals, if that was a plus, if this was root 3 plus 1 here, I would be multiplying by root 3 minus 1, top and bottom. Everybody tracking with me? Whatever sign you have in the denominator, when you have a root and a plus or minus in the denominator, you multiply by exactly that denominator, but opposite sign in the middle. That's called the conjugate. It means opposite sign in the middle, basically. So we had a minus, so I'm going to multiply top and bottom by plus. You tracking with me? Is it coming back a little bit? Remember that from algebra? Sorta? Hopefully your algebra teacher talked about that. All right. So there it is. So this problem just won't seem to end. Now we have to do all that. All right. This has been a half an hour problem. All right. So now we FOIL the top. Boom, boom. So and then 1 times 1 is 1. And now the root 3 is going to go to both. What's root 3 times root 3? Root 9, which is plane 3. And root 3 times 1 is root 3 over. Now what happens down here? It's another FOIL. Root 3, plane 3. Right, remember, two of the same roots make a plane. Root 3 is root 9, plane 3. Right? So I just jump right to plane 3. Root 3, plane 3. So root 3 times 1. Be real careful, it's easy to mess up here. Minus root 3, minus 1. Now what? Can you read all that? I should get rid of those words. Can you read that down there? That's 3, plane 3, plus root 3, minus root 3, minus 1. Now, remember, we're doing so much stuff here. Why are we doing this again? We're trying to get rid of the root from the bottom, right? Trying to get rid of the root from the bottom. See how it works beautifully right here? Everybody see that? Boom, boom. See how they're gone? Positive root 3, negative root 3. See why we use the opposite sign in the middle? That's why we did that. That's why if we start with minus, we use plus, or if they start with plus, we use minus, because that way you'll get 1 plus 1 minus, the roots will go away in the bottom. That's why the conjugate works. That's why you use the opposite sign in the middle. So what's left on the bottom now? 3 minus 1, 2. That's just 2. So I think we finally got this problem. This is a crazy problem. This is going to be like class over once we're done with this problem. So we have a 2 on the bottom. Everybody okay with that? And on the top, now what happens on the top? Root 3 and root 3. How much here's algebra again. Here we are hitting on your algebra background. And I'm glad to help. Please come talk to me. This is exactly what I want to help you with. Do you remember the root rules? What are the root rules? How do you add root 3 and root 3 from your algebra days? Well, let's do the 3 and 1 first off. The 3 and 1, that's just 4. We can do that. That's just 4. Right? 3 and 1 is 4. But what about root 3 and root 3? How do you add root 3 and root 3? Yeah, it's not root 6. You can't just add the numbers inside the roots. That's not true. Yeah, what you're saying is right on. There's invisible ones. It's like x's. What I always tell my algebra students, the root rules are just like letters. Notice, what would you do with an x plus an x? 2x, huh? Root 3, 2 root 3. It's exactly the same. The root rules, just pretend they're x's. And what if they were different roots? What if it was root 3 and root 2? Well, pretend it's different letters, x and y. What would you do? Nothing, huh? They'd be unlike. Same thing with roots. So the rules for roots are just like their letters. Just pretend they're letters, and that'll work for you. We actually have one more step. This problem will never end. All right, you can divide that 2. Now, everybody, before I do another step, are we okay? There's about 1,000,000 steps. Are we okay with that last among many steps? Is that okay with the conjugate thing? So that's messy business. That's hard, and that's one of the that's one of the harder things in the second algebra class. That's not easy. Practice that. I'm glad to help. Go over that off Sarah's or Roberto will. You know, is everybody okay? I just foiled the top, foiled the bottom. Again, when you have a root in the bottom with a plus or minus, that's the key issue. Not just a root, but a root with plus or minus. Opposite sign in the middle. All right, anyway, to here. Now, there's some million pitfalls in this problem. There's 1,000,000 algebra concepts being tested on this question. Can I go like that? No. Do you know that? That's illegal procedure. The math cops will come for you. You can't do that. Why not? What's the problem? What's the problem in all of algebra? What makes everything hard? I'm telling you, it's plus or minus. You see, if that was times, if that was 4 times 2 root 3, that'd be great. Yeah, just cancel the 2, it's all good. It's the plus and the minus. You really want to try to get, if you're going to move higher, if you want to go to pre-calc and calc and you're going the math science road, you really want to get that one for the language of algebra, pluses and all the hard rules are because of pluses and minuses, right? Why do we have to do this fancy conjugate thing down here? Because we had not just a root, but a plus or minus, right? That's what it says right here. Plus or minus in the root, right? When there's, it's all the time it's plus minus. So remember, plus or, and I always make an analogy. Have I said it to you? I probably have. I say it all the time. What's my analogy for pluses and minuses? Costco shopping. Have I said that? Maybe not. Wow, I haven't said much in here. That's what I do. I guess we haven't run into a lot of these yet. I'm just trying to give something real life to help, right? You go to shop at Costco, Sam's Club, those big warehouse stores. We have 5 kids, so my wife shops at Costco. You buy in bulk. It's all bulk. You go to grab the milk. You know, you pull it out. Well, it's plastic to another one, right? You can't take your scissors to Costco and just cut it. Say, thanks, I just want one. Costco will say, no. We give you a good deal because you buy a lot. You buy in bulk here, right? So that's what pluses and minuses are like in algebra. They glue things together. That's exactly what they do. Pluses and minuses glue things together. That's why they cause a problem with the conjugate. And we have to do with the root, they glue this root to the 1. You got to do your special thing. That's why they're causing a problem up here. Because you can't just cancel those 2's. So think that way. What was it, plus? It was plus. You can't just cancel out those 2's. Why not? Because this part up here says we're a glued together Costco package. 4 and 2 root 3, we're glued together. Meaning if you want to buy something up here, you go like that and buy it all, or you buy nothing. You don't take part. You don't just take the 2. You can't take just the 4. You buy it all, or you buy nothing. That's what pluses and minuses do. If it was times, that's shopping at Save Mart. You can buy just one. That's fine. That's the difference. And that's what causes all the problems pretty much throughout algebra. All the hard rules are because pluses and minuses get involved. And they glue things together and gunk it all up. Anyway, so, okay, well then what do we do? Well, we buy it all. Meaning we do the 2, into the 2, but not just into the 2, also into the 4, huh? You buy them both. 2 goes into 4 2 times, 2 goes into 2 1 time. That's okay. I did both sides of the plus sign. I bought them both. Does that make sense? That's okay. So the final answer is 2 plus 1 root 3, and you don't really need that 1. It's just 2 plus root 3. And we're finally there. There's the answer. You okay with that? 1,000,000 different steps. See, that's a big problem. That's something you should, practice. Make sure you can do what we just did on your own. The homework. Yeah.
So if the number was 3 plus 2 root 3, then we wouldn't be able to do anything to it. It'd just be 3 plus 2 root 3 over 2, since we can't do it to the other one.
Yes, correct. Let me write out what you're saying for everybody to see. I like how you're saying that. You're exactly right. So, like, if I understand you right, I think you're saying, like, if it originally it was a 4, yeah, if instead of a 4, yeah, I see totally. I like exactly how you're saying that. If it was that, Right on the money. Yeah, because in that case, yeah, she's exactly right. I'm glad she gave more examples. You could do nothing. We would just stop right here. Because the 2 doesn't go into the 3, huh? If you can't go into both, then you can do nothing. If you can't buy the whole package, you can't have anything. Right, exactly. That's exactly right. It's both or nothing. Exactly. Good. Is everybody getting the hang of that? Pluses and minuses glue things together. Didn't your algebra teacher talk about Costco? That's what I do with a couple of you guys had me for algebra. You guys know I talk about Costco all the time when I'm teaching algebra because that plus minus thing is the pain, makes all the hard rules in algebra. Plus and minuses glue things together. That's what they do. All right. Good question. Other questions on that one? Yeah.
How would you set up tangent for sine and cosine? Or because at the beginning of this you said you work in sine and cosine.
Yeah. So I don't want to take up too much time, but was it okay? So tangent. Yeah. So I would, because I just don't have good memory, so I just, instead of memorizing something new, I would just work it out the hard way. I would just go, look, that tangent of anything is just sine of that thing over cosine of that thing. So that's got to be true, right? Right there. And then I would just do all the rule we learned for sine, do all the rule we learned for cosine. That's a lot of work, though. Of course, this one wasn't easy either way, huh? So, yeah, that's what I often did because I didn't want to memorize a new formula.
Thank you, I was just curious.
Yeah. Okay, so sine 15, cosine 45, cosine 15. So they're basically saying, hey, they're asking us to go backwards. Do you see they've actually done one all the way out? They're saying, hey, what was this? We just did one. What was it? They're wanting us to think of the formula backwards. They're just making us more and more comfortable with it. Which one is that? When you go sine, cosine, cosine, sine, is that the sine of 2 angles added, or is it the cosine of 2 angles added, or maybe subtracted? Yeah, if you look back, have on your 3x5 card or whatever, sine is sine, cosine, cosine, sine. Cosine is cosine, cosine, sine, sine. So that one is clearly sine, right? Sine. So that must be sine of those 2 angles added. What 2 angles? Well, the 15 and the 45. 15 and 45. In other words, that must be sine of 60 degrees. Can we find sine of 60 degrees? Yeah, just draw a little thing. 60 degrees up here.
They're only asking for degrees.
Oh, really?
They're
Going too far, and we've got plenty to do. We don't want to do more than we need to do. Yeah, you're totally right. This is all they want. Done right there. They just want you to write it that way. Oh, do they have 2 parts? So they do want the other thing? Okay, all right, we'll finish it then. So this is the first answer they want. They want you to, condense it down. Say, well, that's just sine of those 2 angles added, right? That's the sine formula for 2 angles added. So that's sine of those added. That's sine of 60. And then you can just figure out 60, like I was doing. 60's here. It's over a little bit, up a lot, right? Over a small, up a large. Sine is the y, cosine is the x, so that must be root 3 over 2. There it is. Good on that? Just doing the formula backwards. Is all they're having us do on that. Just say, hey, do you recognize this? What is this? Yeah, it's the sine of those 2 angles added. Okay, you want to try that one real quick? So, same kind of thing. They want you to recognize which one that is and write it, kind of do it backwards kind of thing. I have a bunch of old exams up here. After class, feel free to come up, and if you didn't get back your exam 1 or exam 2, I've got all the old ones up here. All right, you guys doing okay on that? So again, it's sine, cosine, cosine, sine. So that's the sine formula again, isn't it? It's not the cosine. The cosine is cosine, cosine, sine, sine. So it's the sine. But it's them subtracted, isn't it? Because there's minus in the middle. So it's the sine of those two angles subtracted. Be good there? Is that making sense? And so that'll be the sine of 7 pi minus 1 pi. What's that? 6 pi over 12. Oh, so that's just sine of pi over 2, isn't it? Sine pi over 2? So that's the first answer they want. And then part B, they're going to ask you to find this. So there's the first answer. Now go on and find what is the sine of pi over 2. Go ahead and try that real quick. Give you a second to do that. So pi over 2, that's 180 over 2. That's the sine of 180 over 2. Sine of 90 degrees. 90 degrees is straight up here. So how do you do sine there? Well, remember, it's all about the coordinates. X coordinate, cosine, Y coordinate, sine. What's the coordinates of that point? Over 0, up 1. That dot right there. Right? You can do it for, it doesn't have to just be for 30, 45, 60. Any angle, find the dot, find the x and y coordinates. The x is always cosine, the y is always sine at that angle spot at 90 degrees straight up. Cosine is 0, sine is 1. What do we want? We want sine. It's 1. Good there? So you could do all that without a calculator, right? That'll be on the non-calculator part. Don't need a calculator for any of those problems. Questions on that one? All right. Okay, so here we go. So sine of 3 pi over 2 minus theta. Don't worry about the negative cosine. We'll get to that later. Let's just start with the left side. Sine of 3 pi over 2 minus theta. So that's two angles subtracted. That's the sine of A minus B, isn't it? So what's the formula for that? Sine, cosine, cosine, sine, and it's minus. Sine is our friend. He keeps the same sign. So write in the angles. 3 pi over 2 theta. 3 pi over 2 theta. Good so far? Well, in fact, that's the answer to part A right there, isn't it? So I just did they just want me to do the formula for the left side for part A. Good to there so far? Now the question is, why would that just equal negative cosine theta? Why would this, all that big mess, just be simply negative cosine theta? Well, I suppose if we figure out sine of 3 pi over 2 and cosine of 3 pi over 2, something nice will happen. My guess is this is going to be 0 and this will be negative 1, and that'll make the answer negative cosine theta, you see. That's in fact what they are. Let's see it. Do you know that already? What's 3 pi over 2? 3 pi over 2, somewhere to write it, 3 pi over 2 is 3 times 180 over 2, right? Put in 180 for pi, like we always do. 2 goes into 180, 90 times 3 times 90, 270. So it's 270 degrees. So this is 270 degrees, and this is 270 degrees. Okay, so if you do 270 degrees on the unit circle, that's down here, isn't it? 270. You guys with me? And what are the coordinates of that point? And that's how you find sine and cosine. Find the coordinates. So what is this point is how far over, how far up or down? What is it? Over 0, down 1, isn't it? Isn't that dot over 0, down 1? Make it a little bigger there. over 0 down 1. And that's cosine is x, sine is y. See how the sine is -1? Like I predicted, and cosine is 0. So then this is all -1 times cos theta plus 0 times sine theta. So 0 times anything, that just drops off, negative cos theta. That's why it becomes that. Questions on that? Now what name do you call that? I don't know what name you call that. It's this. It's figuring out the angles. You call it figuring out the angles. They don't have those words though. No identity is required. Evaluate the previous question wherever. But yeah. That sounds good to me. I think it's E. It's because it's not Pythagorean identity. It's not reciprocal identity. It's not quotient identity. It's not even odd identity. Yeah, must be E. I'll go back and check. But is that okay? That makes sense how we did that? So I just figured out, because I can find the sine of 3 pi over 2, and I can find the cosine of 3 pi over 2. Those are 270 degrees down here. Over 0, down 1 is the coordinates of that dot. Cosine is x, sine is y. So the sine here, this is -1, and this cosine is 0. Yeah, so that's sine theta. I don't know what theta is. That just stays sine theta.
And on the bottom, what happens to it on the bottom down there?
Oh, 0 times anything?
Oh, okay.
It just goes away.
I didn't see that.
Oh, yeah. So 0 times anything, it just goes away because of the 0. Yeah, good question. Is that good? So yeah, so the one on the right just drops out because 0 times anything is just 0. That's just gone. And -1 times cosine theta. All we have left on that. That good? All right. So remember, so on these problems, you just start with the left side. Start with the left side. Tangent of 2 pi plus theta. So just start with the left side. Let me write the formula again. It's, in fact, maybe I should do that first. Write the formula for you. Tangent of A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. So there's the formula. So now, tangent of 2 pi plus theta. So go ahead and plug in the A is the 2 pi, the B is the theta. So go ahead and plug those in to that formula, and then see if you can simplify from there. Like figure out what is the tangent of 2 pi. Tangent A, tangent B, tangent 2 pi, tangent theta, over 1 minus tangent 2 pi times tangent theta. We good to there so far? I just plugged in the A, B. The A is 2 pi, the B is theta. Okay, now, so that's the first answer. That's the first answer they want. I assume there's 2 answers here, and then they want you to figure out the final answer from there. So let's do that. So that's the first answer they want you to type in. And then, what is the tangent of 2 pi? You could figure that out, right? Let me give you a second to try that. Find the tangent of 2 pi. Remember, pi is 180, right? So whenever we have pi, we just put in 180. Pi is 180. So that's 2 times 180. That's 360 degrees. That's right here. So that's the dot we're talking about, huh? That's the dot we're talking about, 360. And then you want to write the coordinates of that dot. how far over, the xy coordinates, how far over, how far up. So that is over 1, up 0, isn't it? That dot. And let you finish it from there. How we doing? Getting an answer there?
Zero?
Yeah, right. Because this is cosine, this is sine. Cosine's always x, sine's always y. Right? So tangent is sine over cosine. Right? What's the sine? 0. It's cosine 1, 0 over 1, 0. Tangent is 0. So that means, going back to the original question, tangent of 2 pi, that's 0. And tangent of 2 pi right here, that's 0. So this is 0 plus tan theta over 1 minus 0 times tan theta. Good? Just putting in 0 everywhere we got tan 2 pi. Now that we know tan 2 pi is 0. Bring it up to here. What do we got? 0 plus tan 2 theta. Tan theta. That's just tan theta over 1 minus 0. It's tan theta over 1 is tan theta, which is what they said from the beginning. It's just tan theta. We have now proven it is true. Does that make sense? We good with that? I don't know if they want us to give a reason or a name to that. I'll go back. But questions on that? See, now you able to figure those out? Tan 2 pi is 360. According to that point is over 1 up 0. Cosine is x, sine is y. Tangent is sine over cosine, 0 over 1, 0. And then just plug it in everywhere. It just becomes tan theta. No questions? We good? To number 14. Skip 11, 12, 13. I'll come back maybe. So 11, 12, 13. So here's number 14. And it's basically saying here's a way to figure out a formula for the tangent of 2 alpha. Alpha is their angle here. So how can you figure out the formula for tangent of 2 alpha? I make my alphas a little funny. It's just A in the Greek alphabet. All that alpha is just A in the Greek alphabet. So basically they're saying, look, they have you do a little proof here where they, in the last section, alpha plus alpha, alpha plus alpha, 2 alpha is just alpha plus alpha. Right? We good with that? They're saying, look, you can just write that 2 alpha as alpha plus alpha. Okay, great. That makes sense. 2 alpha is alpha plus alpha. So what? Well, then you can use the tangent formula, the one I've been writing on the screen a couple times, which is, which I don't remember. What is it? Tangent of A plus tangent of B over 1 minus tangent of A times tangent of B, right? We can use that one where this is the A and this is the B. They're both alpha. Both A and B are alpha. Does that make sense? See what we're doing? Whenever you have tangent of A plus B, 2 angles added, it's this formula, and I'm saying the A and the B are both just alpha. So this becomes then tangent alpha plus tangent alpha, right? A and B are both alpha. And this is times here. 1 minus tangent alpha times tangent alpha. Does everybody see what I'm saying? If they give you 2 alpha, that's just alpha plus alpha. A and B are both just alpha. So plug in alpha for A and B. And then simplify. Tangent alpha plus tangent alpha, that's 2 tangent alpha. Tangent alpha times tangent alpha is tangent squared alpha. And that's what they did. That's the final step right here. What are the reasons for that? Well, they use sum and difference formula. That's what this is, the sum difference formula. Basic arithmetic. Yeah, that's all I did. I just added two tan alphas and multiplied two tan alphas. There we go. Is that good? Questions on that? Just remember what. Okay, yeah. So they're giving me the sine of alpha is 40 over 41 right here. Sine of alpha is 40 over 41. And alpha is in quadrant 1. Sine of beta is 12/13. Beta is in quadrant 2. Yes. So how are we going to go about getting these? Well, they're asking me down here, they're saying, what is the cosine of alpha plus beta? That's what they're asking for in part A. That's what they're going to do first. Then in a minute, they're going to ask for sine, and then they're going to ask for tangent. So part B and C. These are long, and these are important. These are valuable. Cosine of alpha plus beta. And so how do we do it? What's the formula for cosine of two angles added? It's cosine, sine, and cosine is not our friend, meaning he switches signs. Whatever's in the middle, opposite in the formula. So alpha, beta. Good so far. That's just using the basic formula. Cosine of two angles added is the subtraction of two cosines multiplied and two sines multiplied. That's the basic formula. We good? So far. I'm hoping. Are we good so far? That's just the basic formula there, right? Cosine of two angles added is cosine, sine. And you do the opposite sign for cosine. If he starts with plus, you put minus in the formula. Okay, now, so basically there's 4 pieces to the puzzle. There's 4 pieces here. I need to find cosine alpha, I need to find cosine beta, I need to find sine alpha, I need to find sine beta. Once I get those 4 pieces, put them all together, get your final answer. You with me? 2 of them I already have. Sine alpha is 40 over 41, right here. That's just 40 over 41, no mystery at all. Good? Bring down the minus sign. It's a big minus sign there. Bring down the minus sign. And sine beta. Sine beta, right there, 12/13. And those are times. Right, this is times and times. Right, nothing between them, understood times. Okay, well then, I need to know cosine alpha and cosine beta, don't I? If I can plug those in, then I can work out this problem. Everybody see where I'm at? How do I find cosine alpha? I don't have cosine alpha. They gave me sine beta and sine alpha. They didn't give me cosine of anything. How am I going to do that?
Do the same thing.
I'm going to draw a triangle. Yeah, remember these we did before? This is super important. Whenever your teacher says that, that means it will be on the test. Of course, you'll see it on the practice exam. You won't be surprised. But the reason it is because this is in calculus. As you know, I'm always thinking about your future, getting you ready for the future, and they do this a lot in pre-calc and calculus, where you draw these little triangles and you figure out things. So that's what you have to do here. So let's do that. So I'm going to come over here. To find cosine alpha, I'm going to have to draw a little alpha triangle. What do I mean by an alpha triangle? Well, I mean they're telling me the sine of alpha is 40 over 41, and alpha is in quadrant 1. So that means I can go to quadrant 1, put a triangle. I don't know exactly where. I'll just put it wherever, and say this is angle alpha, and make a little triangle there. You don't need the whole circle thing. It's just somewhere in quadrant 1, you have a right triangle with alpha as an angle. You with me? They're telling me alpha is some angle, I don't know what it is, in quadrant 1, and the sine of alpha, they're telling me, is 40 over 41. Remember SOHCAHTOA? We did these before, right? In the last exam, where you got to make these little triangles. Here it is again, super important. One of the most important things in this class in trigonometry is being able to make these little triangles, because it's so useful later. Sine of alpha, sine is opposite over hypotenuse. So this is alpha here, opposite hypotenuse, right? So the opposite is 40. The hypotenuse is 41. 40 over 41. You tracking with me? So I should also be able to find the adjacent. How can I find the adjacent? What I do Pythagorean, huh? Pythagorean. A squared, where I'm running out of, maybe I better put it here. Yeah. A squared plus B squared is C squared. Pythagorean theorem. Call this X or whatever. Which one is the C? In the X, the 40, and the 41. 41 is the C. It's the side across from the right angle hypotenuse, right? So that's the one you got to get. The other two, the order doesn't matter. Whatever. X squared plus 40 squared or 40 squared plus X squared, whatever. Doesn't matter. But the 41 goes alone. He's the hypotenuse. So there we go. So that's, use your calculator. What's that, 1600? And what's 41 squared?
1681.
1681, thank you. 1681, bring it over here. X squared plus 1600. 1681, subtract 1600. So x squared is 81. Root it. X is 9. So come back. X is 9. So what was all that for? Well, now I can find cosine alpha. Right? Because this is an alpha triangle. What's cosine? Adjacent over hypotenuse. It's 9 over 41. It's got to be 9 over 41, doesn't it? So I was able to figure that out. And now we got to do all that again for cosine beta. We got to make a beta triangle. That was the alpha triangle. Beta is a completely different angle in a completely different quadrant. Right? Beta is in quadrant 2, didn't they say? Yeah, right here. Beta is in quadrant 2. Beta is a completely different angle in a completely different quadrant. I got to do all that same work again with the Pythagorean and all that to do a beta triangle. So let's do that. Come over here. Quadrant 2. So beta is over here in quadrant 2. Make a right triangle in quadrant 2. And they're telling me sine of beta is 12/13. Sine is opposite over hypotenuse. Well, let me let you do that. So go ahead. So make your little beta triangle. You'll get more out of it than if I whip it out. So make your beta triangle. Sine of beta is 12/13, opposite over hypotenuse. And then do the Pythagorean to find the third side. Once you have the third side, you should be able to get cosine of beta, because that's adjacent over hypotenuse. So sine of beta, 12/13, opposite over hypotenuse. That good? And then we got to find this side, call it x. So 12 squared plus, I'm running out of room there. So 12 squared plus x squared is 13 squared. So that's 144 plus x squared is 169. Subtract the 144. X squared is what? 25. So root it, x is 5. Yeah, as far as the positive negative, you're right, it is -5. But if you're like, when I taught my daughters this year or two ago, they didn't like to mess with the signs. They would just do the SOHCAHTOA, the all students say calculus to know the sign. So either way, you're technically it is -5 because it's back 5, and if you just do that, you'll get the signs right. Or you could ignore all that and just say, look, I'm just going to remember all students take calculus, and that'll always give me the correct signs. So in the second quadrant, only the sign is positive. cosine is negative. So I know this is going to be negative. This cosine of beta is going to be negative something. Because in the second quadrant, cosine is negative. Only sine is positive. So what is it? Adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse. 5/12. It is indeed negative 5/12. Is that good? Now we can figure all that out. Now we can finish the problem. Good to there? So far? So now, get this out of the way and I'll finish up the problem.
It's supposed to be negative 5/13.
Oh, thank you. Yeah, 5/13. That's right. I was testing you. Wendy was right. Yeah, thanks. I messed up. The hypotenuse is 13, right? Negative 5/13. Not 12ths. All right, and then work it out from there. So just use your calculator. Top times top, bottom times bottom. Nothing more fancy than that. 5 times 9, 45. Minus 45. And what's 41 times 13? 410 and 5.
533.
What is it?
533.
533. Thank you. Minus. And this will be 480 over 533. Subtract, do those in your calculator, you get minus 525, I think, over 533. There we go. What did we do there? We had a sine of an alpha angle and a sine of a beta angle, and just from that, we were able to figure out the cosine of those two angles added. It's kind of impressive what we could do from that little information. And that's just part A. But B and C will be cake now, because we're just going to keep using this and this again and again. And we won't have to redo it. So let me show you. So we got that part down. Is that good? For part A? Questions on that part A? That's a hard one. Definitely practice it. Now let's do part B and C. B, here, I'll just put it here fresh again. B is sine. So now they want sine of alpha plus beta. Okay, so write out the sine formula. Sine, cosine, sine, alpha, beta, and he's plus sine just keeps the same sign in the formula as he has in the original, right? Cosine's the one that switches. Okay, so there it is. Now, 4 pieces to the puzzle. We already have sine alpha. Sine alpha right here is 40 over 41. We already have sine beta. Sine beta right here is 12/13. Again, we have the two sines. What we don't have is the two cosines, but actually now we do. We did all the triangle work back on part A. You don't have to redo it. Just go back and grab cosine beta. What's cosine beta? Right here. Cosine beta is what we just figured out, minus 5/13, right? That's cosine beta. So minus 5/13. And then what's cosine alpha? Let's go back and grab it. Cosine alpha right here, 9/41. 9/41. And then just work that out. So 40 times 5 is that minus 200. 41 times 13, it's the same thing we did last time. Yeah, 41 times 13 is 533. Same denominator as we had a minute ago. 9 times 12, 90, 108 over 533. And then what's that, minus 92? I think. There we go. Much easier, right? Because you've already done the alpha triangle work and the beta triangle work. And we'll do tangent. It'll be 2 steps. You got that down okay? So part A said do cosine, part B said do sine, and then part C is going to be tangent. Why will tangent be so easy? What's tangent? Sine over cosine. We got the answer for sine. We got the answer for cosine. Put them over each other. Right? Here, this is the answer for sine of alpha plus beta. Back here's the answer cosine of alpha plus beta. And now they want tangent? So it's just the sine answer over the cosine answer, isn't it? So go to part C and say, okay, you guys want tangent of these angles added? Well, that's just going to be sine of the angles added, the answer for that, over the cosine. Tangent is sine over cosine. The sine answer was minus 92 5/33. Minus 92 5/33. And the cosine answer, cosine of alpha plus beta, is minus 525 5/33. Like that. And then, you know what to do. You got one fraction on the bottom, just flip it up. So minus 92 over 533 times 533 over minus 525. Two negatives is going to be positive, isn't it? 533 cancel. 92 over 525. There it is. So it wasn't so bad. I mean, it is bad. It's a long problem. But once you got the alpha triangle work and the beta triangle work, the rest flows. Questions on that one? We good? All is well? All right. Let's move ahead then. Everybody okay with this stuff here? It's all good? Am I going back and forth? Everybody get that copy down? Does this help? Oh, just kidding. Sorry. Okay, so try that one. They're asking for the cosine of A plus B. Or alpha plus beta. So first step is to write out the cosine formula. So first step, just write out the cosine formula. You have it in your notes a couple times now. So write out that cosine formula. And then you'll have 4 pieces to the puzzle. Cosine, cosine, sine, sine, right? Alpha, beta, alpha, beta. And cosine, does cosine keep the same sign or the opposite sign? He's not our friend, he's opposite. So this plus leads to minus there. Good, so cosine is the one that goes cosine, cosine, sine, sine, and sine's the one that goes sine, cosine, cosine, sine. No, put them on your 3x5 card. All right, there you go, you got 4 pieces to the puzzle. 2 of the pieces have already been given you, haven't they? 2 pieces have already been handed you. Cosine alpha, right here. That's 12/13. And sine beta, right here. That's minus 2/5. The other 2, you need to make an alpha triangle and a beta triangle to find the other 2. Let's start with the alpha triangle. And by the way, yeah, let me say this, guys and gals. I think this might help. You don't have to really put it in the correct quadrant at first. If you want, if it's easier for you, what you could do is just say, look, I'm just going to make a little triangle here. I don't care about all the first quadrant, second. I'll do the all students take calculus. So remember, that's how my daughters. It was a lot easier for them that way. So maybe that's easier for you as well. You can just make a little triangle in the first quadrant. You can just always do your work in the first quadrant if you want, if that's easier, and then just figure out the sign later based on the all students take calculus. So just stick the alpha in the first quadrant. Just say cosine of alpha is 12/13. So let me remember the SOHCAHTOA. SOHCAHTOA. Try to do the alpha triangle. Cosine of alpha is 12/13. Put it in that triangle. Give you a minute. Feel free to check with each other. Feel free to work together, see if you're getting the same thing on this. I want you to get as much as you can out of these almost 2 hours. We meet twice a week, so if you can come out the door here today knowing how to do these, that's big gain. These are some of the hardest ones. So see if you can get it. Check with those around you. I usually came out of math lecture understanding a very small part of what went on. It would have to spend a lot of time later. But I was always happy if I could come out kind of half getting it. So see if you can get this. Try this. It'll be benefit to you, and I think you'll feel encouraged to go on that homework if you come out feeling good. So try that. See if you can get this one. So the cosine is adjacent over hypotenuse, right? So remember, this is the adjacent side, the opposite, and the hypotenuse. We okay with the how those sides work, right? Adjacent, opposite means across from, right? That's why that's opposite from alpha. Cosine is, so 12 over 13, that means this one be 12, this one be 13. We good there? So now you need to find the opposite. Let me give you a hint to help. It's nice to memorize, and I have a terrible memory, so when I say this will be, you should really believe it, because I avoid memory whenever I can. So if it's worth it, it's usually a valuable thing. It's 3, 4, 5. That's that one, and 5, 12, 13. Those come up a lot. 3, 4, 5, those are what we call Pythagorean triples, meaning 3 squared plus 4 squared is 5 squared, and 5 squared plus 12 squared is 13 squared. They just use those three a lot. So if you just know to look for them, 3, 4, 5, and 5, 12, 13. When you see 12, 13, you go, oh, that's 5. It's got to be 5. And you can skip the Pythagorean work, because you know they use 5, 12, 13. But anyway, I'll do it formally anyway. Call it X, or I'll call it Y, because it's up and down, whatever. Call it Joe, whatever you want. It doesn't really matter. So A squared plus B squared is C squared. So Y squared plus 12 squared is 13 squared. Y squared plus 144 is 169. Subtract the 144. Y squared is, what's that, 25? See how Y is 5? So if you just remember 5, 12, 13, it comes up a lot. 3, 4, 5 and 5, 12, 13, they use those a lot. Those are real convenient Pythagorean triples. Anyway, all right, great. So there's the alpha triangle completed. Now use that to find the sine of alpha. You should be able to come up with the sine of alpha. Now that you have the alpha triangle finished, all three sides, can you find the sine of alpha? So find the sine of alpha. So what's the sine of alpha? Yeah, because sine is opposite over hypotenuse. Opposite over hypotenuse, 5 over 13. Oh yeah, now we can do the sine, huh? Yeah, let me now. Yeah, good. I was moving right on. It's quadrant 4 actually. In quadrant 4, all students take calculus. Only cosine is positive, so sine is negative 5/13. Good. Right? The all students take calculus tell you which functions are positive. They're all positive. Only sine, only tangent, only cosine, and their reciprocals are positive. The other 4 trig functions are negative in those quadrants. So, good. Can we do the beta in one now? So let's do the beta triangle. So now you need to draw a new triangle, draw a beta triangle. Use the original fact they gave you up here. Sine of beta is minus 2/5. And if you want, just skip the minus. That's what I'm saying. That my daughters appreciated that. They didn't want to worry about so much details. They would just say, Dad, we're skipping the signs. We're just going to put the 2 and the 5, and we'll figure out the signs there. That works. You can do that. Don't worry about the negative. Just put 2 and 5 in the triangle. Just put in the first quadrant. Do the same thing. So, make a beta triangle. You just put it in the first quadrant. Sine of beta is minus 2/5. Sine, as you know, is opposite. So here's the adjacent. the opposite, the hypotenuse. Sine is 2/5, so you say 2 over 5. Don't worry about the minus. Like I said, you can do that later. 2/5. Okay, find the x. So what's that going to be? You got to do the Pythagorean. Pythagorean again for the beta triangle. So Pythagorean, a squared plus b squared is c squared. So that would be what? X squared plus 2 squared is 5 squared. X squared plus 4 is 25. X squared is 21. So x is the root of 21. X must be the root of 21. We good? To there? That okay? And now, and what do we want? Cosine of beta. What's cosine? Cosine is adjacent over hypotenuse. So it's root 21 over 5, but we got to do the quadrant. Beta, says right here, beta is in quadrant 3. So beta is here in quadrant 3, and all students take calculus. So only tangent is positive in quadrant 3, which means cosine and sine are both negative. So cosine of beta in quadrant 3 must be negative. Negative. What is it? Adjacent over hypotenuse. So root 21 over 5. Get that out of the way if that's okay. And there we go. Negative root 21 over 5. Big old minus in the middle. I don't know why I've got this line here. Put that back to where it was. What was that? Negative 5/13. Like that. There we go.
Is that allowance, square root of 21 over 5 is negative?
Mm-hmm. Yeah, because it's beta. So this is the beta triangle. It's not. No, I just put this in the first quadrant, so you can't get the sign out of that because I'm not really putting it in the right quadrant. But the way I got the signs, I came up here and it says beta is in quadrant 3. So quadrant 3 is here, and only tangent is positive.
Since over there on top it says negative 2 over 5, so the negative applies to the 5 also.
So what's that?
Up there.
The negative 2/5. And the negative applies to the 5 also. Remember, I ignored the negative. I completely ignored it because I just put it in the first quadrant. So what I'm suggesting to you is an easy way, because if you don't want to worry about signs and the numbers and everything at once, you can just ignore the negative and positive and just put the triangle in the first quadrant. Do you realize when I put it in the first quadrant, I'm making everything positive, because remember, everything's positive in the first quadrant. So I'm really ignoring the minus and saying, I can handle the sign later with the all students take calculus. I can make those all correct later. Let me just ignore it for now. Put it in the, I don't make the 2, I keep 2 and 5 positive. I just ignore the negative. Do the Pythagorean work, find the root 21. Then I go, okay, now I know it's root 20 over 5, but is it positive or negative? Well, I go back and go, where's beta? Beta's quadrant 3. Only tangent's positive. Oh, cosine's negative. Just like that. And then we work it out. So what is this? This will be positive times negative. It's negative 12 root 21 over 5 times 13, 65. Minus and minus. Oh, and minus. 3 minuses is minus, huh? 3 minuses is minus, 2 minuses plus, 5 times 2 is 10. Over 5 times 13, 65. What do you do with that? Remember, roots, 12 root 21. Remember, root is like an x. So this is like minus 12x, minus 10. They're unlike terms. Just keep them separate, right? So it's just minus 12 root 21 minus 10 over 65. Just make it one fraction, but you cannot combine those two on the top because, like I was telling you, a root is like an x. So these are unlike terms. You can't subtract them. That's it right there. Good on that? And here's an example of the Costco glue thing. You might say, could I divide 10 and 65 both by 5? Yeah, except for you can't do the 12 also. Remember the minus here glues them, which says you do both the 10 and the 12. But we don't do the root 21. That's a different world. He's in the root. But you do all 3 outside numbers are all divided by the same thing or nothing because of the Costco glue, because of this minus gluing them together in the top, which means you can't just mess with the 10 unless you also mess with the 12. So if all 3 of those, if they were all divisible by 2 or all divisible by 5, then we would do it, but they're not. So we do nothing. It's all or nothing. Is that good? How y'all doing? A lot of algebra mess here. It's really algebra, isn't it? It's algebra applied to trig. It's good. If you want to go the way of pre-calc calc, you got to be a growing master of algebra. Growing master, not just I finished algebra 1, algebra 2. No, I really know those root rules. I really know fractions and complex fractions. That's it. That's why people don't make it up the line in math. It's their algebra doesn't become mastered enough because it just gets worse and worse and worse. Pre-calc and calc, just more and more mess of algebra. So you can do it, but you got to get on these details. Anytime you don't understand an algebra step, if you want to go that way, you need to get with the tutor or me or a friend and somehow figure out that algebra manipulation. That's the future. That'll serve you well. That's why people make it or don't make it in calculus. It's algebra. It's algebra skills. That's really it. It's all this kind of. Okay, so the graph with equation y equals 2 cosine whatever is shown to the right in a 0 to, what's that mean? A 0 2 pi over 2. Negative 2, 2, 1. I guess, okay. What they mean is they're going from 0 to 2 pi. That's a funny way. They're saying x min, x max, like on the graphing window, 0 to 2 pi. And the pi over 2 means how much each of these marks are. Pi over 2, like each of the marks is pi over 2. What do they call that? The scale on the graphing calculator. Anyway, whatever. We're not doing graphing calculator stuff. Negative 2 to positive 2, that's the y minimum, y max. So that means it goes from the bottom of the graph is negative 2, the top is positive 2. Like here's the axis system, in other words, making sense. So this is, yeah, maybe I'm confusing you terribly. This is x, and this is, I'm sorry, this is 0, and this is 2 pi, is what they're saying. And the negative 2, positive 2 are the y, this is the y axis here. Negative 2, positive 2. That's what they're saying when they say the window. All right, so what? Describe the graph using another equation. Describe the graph using another equation. Oh, yeah. Yeah, just look at that for a second. So everybody first off, okay with how I put the numbers in there. When they say that graphing window, they mean a graphing calculator window, they're saying it goes from x0 to x2 pi. Don't worry about the pi over 2. Just from 0 here to 2 pi there. They're just saying where x starts and ends in that window, that rectangle. And y goes from negative 2 in the bottom down here to positive 2 in the top in that window. Good? So far so good. They're just telling me how big that window is. Left side, right side, bottom. They're just going left, right, bottom, top. Don't worry about the other number, whatever. Who cares? It does not important for us. Just 0 to 2 pi, left, right, negative 2 to positive 2, top, bottom, or bottom, top. All right, so what? So what is this? How high is that one? 1. It's halfway up, right? And how far down is this? Negative 1. So the actual thing goes from positive 1 to negative 1 then, doesn't it? And it starts high and ends high. What graph is that? That's normal cosine, right? So the point is, this, we can tell from the picture, is just normal cosine. There's our answer. That's all they're wanting you to see. That if you type in this right here, you can tell from the picture, since it just starts at 1, ends at 1, starts high, finishes high, that's normal cosine. That's what cosine normally does. No shifts. You think, yeah, but what about this shift? And, well, obviously, when you do the 2 pi shift with the minus x, for whatever reason, it turns it back into normal cosine. I can tell by the picture. That's all they're saying on this one. Good on that? Just a normal cosine in the end. It's not sine, because sine would start in the middle and end in the middle, right? It's not a negative cosine, because it'd be the u turned upside down. It's not. All right, do a little bit of that. Maybe I should do number 13. But anyway, so all right, so here's number 11. This is number 11. And they basically want me to prove this theorem. They're going to go step by step. So on the top, up here, they say, all right, take sine of alpha minus beta, and they say just do the normal, that's just the normal formula for sine of a minus b, isn't it? That's just the normal formula, nothing special there. That's just sine, cosine, sine, minus, is still minus for sine. He doesn't change the sign. So there's nothing fancy there. Let's just write it out. And then they say, okay, now separate it over a common denominator. You know what I mean? Like if you have like 5 minus 3 over 2, you can say that's 5 halves minus 3 halves kind of thing, right? That's all they're doing here. They said, look, you got this over the denominator, so put it there. And then you got this over the denominator, so put it there. They just separated it. See what they did there? Nothing too amazing. They just separated it into two fractions, just like I did over here with the 5 and the 3, both over 2, right? That's all they did. Can everybody see that? Can you see that they did that? And then they took this and they said, okay, now what can we do with that? Nothing. That one just stays the same, but this one is a big 1. See how the cosines cancel and the sines cancel? Right? So far, so good? Now there's one more. Am I racing too fast? Now there's one more step. What is sine over cosine of the same angle? Sine alpha over cosine alpha is tangent alpha, right? So this is tan alpha. Tan alpha. And what's cosine over sine? That's cotan for beta. Minus 1, which is exactly what they want me to prove. Good on that? And I don't know what name they give that. I never know the names too well. So there we go. So that's just that. All right, so let me show you this real quick. So cosine of alpha plus beta, right there they just did the cosine formula. Cosine, cosine, sine, sine. No big deal. And then cosine of alpha minus beta, right there they did that one. So I just wrote those out longhand. Good so far? Just wrote those, because cosine is cosine, cosine, sine, sine. They did it twice. And cosine switches signs, right? Plus in the beginning, minus in the formula. Minus in the beginning, plus in the formula. So they just wrote those out longhand. Then, here's the tricky step. They had you do a big, ugly FOIL. It's a big and it's ugly FOIL. How so? What exactly? Let me show you. So they took this big mess, if you can see it here, and they said, all right, this is one term. This is a second term. This is a term. And this is a term. And they said, all right, this times this and that. They're doing a big FOIL. See the parentheses here? Right? They're doing a big FOIL. So cosine, cosine times cosine, cosine. What do you get? Cosine squared, cosine squared. See that? And then this times this will be cosine alpha, cosine beta, sine alpha, sine beta, won't it? Where's that? Well, then when you do the other one, this times this is minus sine alpha, sine beta, cosine alpha, cosine beta, and these cancel. They're the same thing, just different order. And then this times this is this, minus sine squared alpha, sine squared beta. So they FOILed it. See how they got that big mess? And then they said, oh, by the way, remember 1 minus cosine squared is always sine squared? Remember I can always make that substitution? 1 minus cosine squared is sine squared. So they said, hey, stick that in for sine squared beta right here. Stick it in right here. Stick in 1 minus cosine squared. So they go. So when you do that, you get this mess. I could show that, but we're running out of time. And then lastly, they say regroup. So how are they regrouping? What are they doing? Oh, they factor out cosine squared. See how this guy and this guy both have cosine squared? So they factor out cosine squared beta, and it's cosine squared alpha plus sine squared alpha. See that? Because both these terms have cosine squared beta. Minus, and then you just put the sine squared alpha at the back. See how they did that? They factored cosine squared beta out of those two. Am I losing you? Is that a tricky step? Are you okay with that? Right, that'd be like saying cosine squared beta times x plus sine squared alpha times x, and you just factor out the x, right? But instead of the x, it was cosine squared beta. That was the x. That was the x they both had. Everybody see that? They just factored out the x right here, the cosine squared beta. You see that? And then, what is cosine squared plus sine squared of the same angle? 1. Remember that special formula? So this is just cosine squared beta times 1 minus sine squared alpha, which is what we wanted to prove. All right, well, that's as much as we can